Let's talk about inequalities, and today we're going to focus on absolute value inequalities. Last time we discussed how to solve simple inequalities. Let's think about, there are two cases for the absolute values that we're going to discuss today. Absolute value of x be less than specific constant a or greater than constant a. It could be variables, but we haven't dealt with variables. We're not going to deal with variables, but a could be a variable as well. At the moment, let's assume absolute value of x less than a. What does it mean? Let's think about it this way. I'm going to reuse a number. Absolute value of x. Let's maybe actually use a box and say absolute value of a number is less than 5 or equal to 5. Doesn't matter. What can you replace in this box? Well, there are options. You can replace 1. Absolute value of 1 is definitely less than 5. Absolute value of 4 would be less than 5. Absolute value of 5 would be less than 5. How about negative numbers? Can I go negative 10? Absolute value of 10, negative 10, it becomes 10. 10 is not less than 5, so this is not possible. How about absolute value of negative 5? Is it possible? Absolute value of negative 5 is positive 5. 5 is equal to 5. So this is possible. And you will see that all the numbers between negative 5 to positive 5 would be possible because the absolute value would be a positive number between 0 to 5. Even 0 is possible. 0 is less than 5. So if you have absolute value of x less than or equal to a, that means that number that you put in, the absolute value, must be between a as a positive value and negative a as a negative value. So x must be between a and negative a. We require this to be a to be a positive number. If it's not positive, if you remember, absolute value cannot have a negative outcome. So this would not have any solution. For example, absolute value of x less than negative 1 is not possible. Any number that you put in the absolute value is a positive number, so the outcome is not possible. So this negative 1 cannot be on the right hand side. On the other side, if you look at absolute value of x greater than a, and say what numbers I can replace in a, x for x to be greater than a. If a was something like 2, then you can say I can replace 3, 4, 5, and so on, as well as negative 3, negative 4, negative 5. So all those numbers, either they're greater than a or they are smaller than negative a. They're smaller than negative 2, like negative 3, negative 4, and so on. Okay, so in the first case, you will have an and situation, and in the second case, you will have an or situation. This is what we discussed in the last time in the inequalities, compound inequalities. Let's do a couple of examples, and we will see how to solve these. First example is something like 3 times absolute value of 5 minus x plus 2 less than or equal to 14. What do you do originally? If it was an equality, you always try to isolate the absolute value. So I'm going to do exactly the same thing. Let's subtract 2. I can do that. And then what we have is 3 times absolute value of 5 minus x less than or equal to 2. Subtract it from both sides. This would be 12. You can divide both sides by 3. Since 3 is a positive number, I do not need to flip the inequality. So I have absolute value of 5 minus x less than or equal to 4. If you forget it, what is the compound form? Think about it this way. You have absolute value of something less than or equal to 4. What could this number be? This number could be only between 4 and negative 4. It cannot be larger than that. If it's larger than that, then absolute value is not less than 4. If it's something like negative 10, then the absolute value becomes 10. 10 is not less than 4. So the number that you put in the box has to be between negative 4 and 4. So if you think about this, 5 minus x is a box. What can you say is 5 minus x must be between 4 and negative 4. That's what you can say. If it was strictly less than 4, then you would use strict. But since we have equality, I should say equal is possible as well in both sides, not only one side, both sides. Sorry, let me Make this nice. Okay. So now how do we solve it? Last time we discussed how to solve this. Solve them each separately. -4 less than or equal to 5 minus x. There is a shortcut, but I want you to do it step by step. This way you do not make mistakes. 5 minus x less than or equal to 4. Okay, subtract 5 from both sides. Subtract 5, subtract 5. What do I get on the left side is -9 less than or equal to -x. How do I get rid of the negative sign? I'll multiply negative to both sides. If I multiply a -1 on both sides, what do we get on the left side is 9. Right side becomes x, but since you multiply a negative sign, you have to flip the inequality. So this is your solution to the left side. How about the solution to the right side? Exactly the same idea. Subtract 5. We get -x less than or equal to -1. Multiply by a -1 times -1. What do we get is x. Again, since you multiply negative, you have to flip the inequality. X greater than or equal to 1. This is the right-hand side solution. You can graph the solution and find the interval form of it. Let me draw the solution. I'm going to draw them in one line. You can do it separately or you can do it together. I'm going to draw them different colors so you would see. The solutions are depending on the two constants 1 and 9. Okay. Let's look at this one. I'm going to use color green for this. The solution x less than or equal to 9. If you cannot read it this way, 9 greater than or equal to x is the same as x less than or equal to 9. The direction of the inequality is still the same. X less than or equal to 9. This is the same as 9 greater than or equal to x. So this is 9. Since you have equality option, there is a closed circle. X less than or equal to 9 becomes this section. Everything less than 9. All this area. You do not stop at 1. This is the solution to this equation. How about the solution to the other equation? Let me use a different color. Maybe light blue. Here. Maybe it's not that clear. This one here. I'm going to use black. For x greater than or equal to 1, 1 is a closed circle. Everything greater than 1 would be all this area. This is the solution to the right-hand side. So, is this an AND case or case? Since you have this form of the inequality, this is an AND case. So what do I want? I want the intersection of the solutions. So what is the intersection of the solution? Here, I'm going to use this to color it. The intersection of the solution is this area. This is what they have in common. From 1 to 9. So what is my solution interval set? The interval solution would be, scroll down a bit. The interval solution would be from 1 to 9. This is the solution in interval form. If they ask you to graph it, this is the graph. If they want you to write the solution as a set, you can say all the x's between 9 and greater than 1. You can write it this way as well. It's greater than 1, less than 9. You should have the equality. And x is such that x is greater. Okay. So this is if you have an absolute value less than or equal to a constant. This is the case. Absolute value of something less than or equal to 4. In this case, 5 minus x was in there. How about, let's try this example. How about this example? We go back to color blue. Okay, first isolate the absolute value. Divide both sides by -3. If I divide both sides by -3. What do I get? I get 2y minus 4. Since you divide by a negative number, flip the inequality, greater than 6. Again, you do not need to memorize. You can always look at this and say, whatever it's inside the absolute value, I'm going to call it a number. call it a box or whatever. That box is supposed to be greater than 6. Whatever number you put in here has to be greater than 6. Or it could be a negative number, something like -10, because the absolute value of -10 is still greater than 6. It becomes +10, then it's greater than 6. But this is the case when you have two options. Either the input is greater than 6 or it is smaller than -6. So this input in this case is 2y minus 4. So either 2y minus 4 is greater than 6 or 2y minus 4 is less than -6. As you see, since the question does not have equality, the inequality is a strict inequality, I use the strict inequality for both cases. And now solve each one separately. I'm going to solve 2y minus 4 greater than 6 here. 2y minus 4 greater than 6. And I will solve 2y minus 4 less than -6. At this point, it should be very easy to solve this. And by the way, this is an OR case. So what do you want at the end is the union. Because you want to satisfy at least one of these guys. It doesn't need to satisfy both. Okay, 2y minus 4 greater than 6. Add 4, divide both sides by 2. Would be y. Here, I'm going to do it step by step. 2y greater than 10, divide by 2y greater than 5. And on the other side, same thing. Add 4 becomes -2. So 2y less than -2. Divide both sides by 2. Y less than -1. What are the solution? The solution set. Solution set. All those y's such that either y is greater than 5 or y is less than -1. In this case, you cannot combine these two. I'm going to keep it this way. If you graph it, you'll see sometimes it's possible to combine the solution, but in this case, not possible. I'm going to graph the solution. Here, draw a number line. If you look at each solution has two specific constant. You look at this one has 5 as a constant, as an important point. So here is 5. The other one has -1 as the end point. So this is -1. On the number line, you put these numbers in order. Okay, let's use green for this solution. Y greater than 5. This is 5. Since 5 is not included, use open circle. Greater than 5. All these solutions. And for the other solution, let me use blue maybe. Here. Y less than -1. This is -1. Open circle, since -1 is not included. Because your inequality is not, there's no equal option. It's strictly less than -1. These two. What do I want? Do I want the intersection or the union? Since it's an OR case, you should use the union. So this whole thing becomes your solution. From -infinity to -1 and from 5 to infinity. This is your solution. If it was intersection, then there was these two sections, they do not have an intersection. It becomes an empty set. So let's try to write this solution. How do you write the interval form of it? Interval form. You would say from -infinity to -1. You can write down what you see from -infinity to -1 and from 5 union 5 and infinity. Sometimes instead of using union, they put a comma here in between. Okay. So this is the solution to your equation. Okay, let's try this example. There are a bunch of cases I'm going to mention, and we'll look at each one separately. Here is what you should be careful about. I've already mentioned, but I want you to be more careful when you deal with these cases. Think about this one, it's already simplified. Absolute value is isolated by itself. On the other side, you have a constant. Again, there is no need for memorization. Think about this. You have an absolute value of a number less than -3. What is that number? Could it be 1? Absolute value of 1 is 1. 1 is never less than -3. Absolute value of -1. How about that? That's not possible. How about -10? It becomes +10. Is never less than -3. As you recall, absolute value always have a positive outcome. So it's never possible to be less than a negative number. The outcome of this absolute value is always positive number, whatever that is, or 0. At least it's non-negative. So it's never possible to have less than a negative number. So in these cases, when the absolute value becomes less than a negative number, this has no solution. There is no number that you can find for x to satisfy this equation. How about this one? Absolute value of 2x minus 4 less than or equal to -3. This is a case that has all the real numbers as a solution. I can show you this one. Actually, let me do it step by step, but first I will do it later, but let's think about it this way. You have absolute value of a number greater than -3. What could this number be? Could it be 0? Absolute value of 0 is greater than -3? Yes, it is. How about 10? It is possible. How about 1? It's possible. How about -10? Absolute value of -10 is still positive 10. It's greater than -3. Doesn't really matter what number you put in here. -1, absolute value of it is positive. It's always greater than. So since the left side is always positive, it is always greater than a negative number. This has all real numbers as a solution. Whatever number you pick for x is going to satisfy this inequality. There's a way to solve this as well, similar to what we did already, but I will show you in the next step. But if you look at the question, you can skip ahead and say the left side is always positive, right side is negative. Positive is always greater than or equal to negative number. Actually, the left side could be 0 as well. 0 under positive is always greater. So how about the last case? There are 3 cases. Either right hand side is negative and you have less than, either right hand side is negative and you have greater than or equal, or you have less than or equal to 0. How about this? You have absolute value of some number less than or equal to 0. Could this number be a positive number? Your answer should be no, because whatever that positive is never less than 0. Could it be a negative number? Could it be -3? Absolute value of -3 is +3. +3 is not less than 0. Negative or positive are not possible. But there is a choice here. This number could be 0, since you have the option of equality. If it was strictly less than 0, then there would be no solution, similar to the first case. But since it is possible to be equal to 0, there is a solution here that if this number in here is 0, if the number inside the box is 0, then it is possible. If you look at this inequality, 2x minus 4 less than or equal to 0. If 2x minus 4 was 0, what you get is x equal to 2. Can I replace 2 into the equation, to the inequality? 2 times 2 would be 4 minus 4 is 0. Is 0 less than or equal to 0? Yes, it is. So this would be a solution for your equation. So this is a solution set here. It's not an interval. It's just one number. It is 2 is the only number that satisfies. Again, we can find out these 2 cases. I'm going to show you how to find them. But the idea is very similar to what you do originally. It is only this case that is important to notice, because you cannot set it up as the original way that you set it up. Okay. Oh, actually, you can do that as well, but I suggest you focus on, is it possible to have a number less than a negative number? Is it possible to have a number, absolute value of a number greater than a negative number? Okay, so let's try this. Let me try to show you. There is another case here, but I want to focus on these 3 first. The last one is very similar to the other case that we did here. Is 0. It's the opposite of that. So let's try these 2 first. Let's try absolute value of 2x minus 4 less than negative 3. There's a short way is what we did. So there's a longer way, absolute value of 2x minus 3 less than or equal to negative 3. As we said earlier, there is no solution to this case. But if you go through the same process that we did and say, okay, there are two cases. Either 2x minus 3 is between negative 3 and greater than positive 3. This is by the absolute value of x being less than or equal to a. That number is either between negative 3 or positive 3 in the same order. And you solve each side separately. Say 3 is less than 2x minus 3. And I'll solve the other case and say 2x minus 3 is less than negative 3. And solve each one separately. This is an AND case, since you want to satisfy both cases. Okay, so let's solve this. What is left hand side? Left hand side becomes 2x is greater than 6. Divide both sides by 2, x is greater than 3. I can write it this way, x is greater than 3. Has the same meaning. These two are the same thing. How about this one? This one is 2x is less than 0. So add 3 to both sides. X would be less than 0. Okay, graph your solutions. What is your solution? The graph of it. Sorry, let me fix this straight line. Be a bit better. Okay. X less than 0, this is 0. X less than 0, be anything smaller. Here, this area. How about the other case? This is number 1. This is area 1. How about 2? X greater than 3. This is 3. X greater than 3. This is area 2. Since this is an AND case, you should be looking for the intersection. What is the intersection of these two solutions? What do they have in common? Since there is no overlap, I can say they have nothing in common. So what do I say? I say this guy has no common area, which means there is no solution to satisfy both of them at the same time. And this is exactly what you can say originally. You have an absolute value that is less than a negative number. Absolute value is always positive. It's not possible to have a positive number less than or equal to negative. So that's why you have no solution. That's the first case. Even if you go through the same process, you will end up with no solution. But there is a shorter way to see it that the absolute value shouldn't give you any solution in this case. How about if it was the other case? Let's try the other one. The other one was absolute value of 2x minus 4 greater than or equal to negative 3. Here. Absolute value of 2x minus 3. And instead of 4, I use 3 greater than or equal to negative 3. Okay, you can have strictly greater than negative 3, you can have greater than or equal, does not matter. So let's try this one. Let me change that negative 3 on the right hand side and make it negative 1, so a bit different from the last example. Last example was less than or equal. You had an absolute value which was less than or equal to negative 3. This time it's greater than. What do you expect is, what outcome of this absolute value is always positive? Is it always greater than negative 1? Yes, it is. So the solution should be all real numbers. All real numbers. This is what I expect. So here, let's try it. If you remember, if you have an absolute value of some number x, absolute value of x greater than a or equal, then either x is greater than a or x is less than or equal to a. Is less than or equal to negative a, sorry. So I can say here is either 2x minus 3 is greater than or equal to negative 1, or 2x minus 3 is less than or equal to negative 1 is positive. And this is an OR case. So at the end, what do I want? I want the union of your solution. Okay, so solve each one. You use a different color. 2x minus 3 greater than negative 1. This would be 2x greater than negative positive 2. X greater than or equal to 1. On the other side, you will get 2x less than 4. So x less than or equal to 2. Graph each one. Here. I'm going to use different color for each section so you would see. This is solution 1. X greater than 1. This is 1. X greater than or equal to 1. Here, close circle. Everything greater than 1. All this area. And so on. Goes on forever. How about the other case? Use blue. X less than or equal to 2. Here's 2. X less than or equal to 2. It will be this section. Okay, what is your answer? You shouldn't say 1 to 2. It's not 1 to 2 since our cases here is OR. OR means you want union of all the solution. It's not only this intersection. The intersection would be the common part. Union means all the solution. So what is all the solution? All the solutions cover this part plus the other part. So what is that? That's the whole number line. There is nothing left behind. You covered all the number line. So what is your solution? Your solution is simply all real numbers. And that's what we expected. Here. Absolute value is always greater than a negative number. Whatever you put in here, if you replace in 1, 2 times 1 is 2 minus 3 is negative 1. Absolute value of that is always greater than or equal to negative 1. Whatever number you put in for x, it's going to be possible. This 2x minus 4 less than or equal to 0. I can show you that one as well. Try that one. Absolute value of 2x minus 4 less than or equal to 0. This is the first case that you need to take an intersection because it's less than or equal. Absolute value is less than or equal. So either 2x minus 4 is less than or equal to 0. Sorry. And greater than or equal to negative 0. It was absolute value of x less than a. It would be x between a and negative a. You remember. Okay, so solve each side. Negative 0, by the way, is 0. So 0 greater than or equal to 2x minus 4. Solve that. Then 2x minus 4 less than or equal to 0. Left side becomes add 4 divided both sides by 2. It would be x less than or equal, greater than or equal to 2. Means x greater than or equal to 2, by the way. On the right side, it's add 4 divided both sides by 2. You get x less than or equal to 2. This is an AND case because you want to satisfy both. This form is an AND form. Means you're looking for an intersection. To graph each solution, I'm going to use the color green for this side. Here's 2. X greater than or equal to 2. 2 is included. So here is the area that I want. As well as 2. 2 is included. And how about the other solution? Let me use color black. X less than or equal to 2. This is 2. Everything, sorry. Let me use above it. This is 2. Everything below 2. All this area. What is my solution? Again, remember this was an AND case, so you're looking for intersection. What do they have in common in this area? It's only this number that they have in common. So what is my solution? Solution, x equal to 2. You can write it as 2. And if you remember, originally we said that if the inequality is less than or equal to 0, that means the number inside can be only equal to 0. So 2x minus 4 equal to 0 gives you x equal to 2. That's why we had only one solution, x equal to 2. And sometimes you get an absolute value of 3x plus 3 greater than 0. All this is just to show you that there is possibility that you have no solution. You have all real numbers. You can only have one number. These are all possibilities. And here, let me show you this one. This is a specific case as well. 3x plus 3 greater than 0. This means either 3x plus 3 is greater than 0. This is an OR case. Or 3x plus 3 is less than negative 0. It was greater than a or less than negative a. Solve each one separately. Let's say 3x plus 3 greater than 0. What do I get is 3x is greater than negative 3. Divide both sides by 3. X is greater than negative 1. Or in the other case is 3x plus 3 less than negative 0. Negative 0, by the way, is 0. You can write 0 there. So 3x is less than negative 3. Divide both sides by 3. X is less than negative 1. So graph these solutions. We draw a straight line here. What are the solutions? Solution 1, use the color green. You don't need to use color as long as you do not get confused. You just stick with one color. You need more practice. X greater than negative 1. Here's negative 1. X greater than negative 1. Since negative 1 does not have the equality option, use open circle. Everything greater than negative 1. All these numbers. All this area. How about the other case? The other case is x less than negative 1 for this part. Negative 1 again is not included. All the numbers less than negative 1. Everything in this. So what is my solution? My solution is, since it's OR case, I should use a union. So what is the union of these two sections? What is all the solution together would be everything up to here. You see, in both cases, negative 1 is not possible. It would be everything in this shaded area. So how do I write this solution as an interval? I say it is possible from negative infinity to negative 1, but negative 1 is not possible, so open parentheses. And then again from negative 1 to positive infinity. Everything except negative 1 is possible. Any other number is possible. If you pick 2, 2 is here. If you pick negative 3, negative 3 is here. Negative 1.1, negative 1.1, it's somewhere here. Negative 0.9, somewhere here. It's acceptable. All these are acceptable except the point negative 1. There is a shorter way to write this as well. This interval could be written as r minus negative 1, because it means from all real numbers, I want to take out negative 1. Instead of minus, sometimes they use backslash. Maybe I should use backslash. More accurate. It means exclude negative 1 from the real values. That would be the solution. I hope it is clear. Absolute value is the case that you either write it as an AND case or an OR case and you take the intersection. Okay, let's stop here.